Vistron 2021 Object Detection in Images Challenge. Next, I will introduce our work from the following three aspects. Firstly, died in drones. The challenge containing 10,209 static images captured by drone platform in different places at different heights. The goal of this task is to predict bounding boxes of objects of 10 predefined classes, including pedestrian, person, car, van, bus, truck, motor, bicycle, all-in tricycle, and tricycle with real-valued confidences. In the work, we carefully analyzed the characteristic of VistrongerDet 2021 dataset, and the main reason for the low detection performance are tiny objects, wide scale span, long tail distribution, and the confusion of similar classes. Secondly, introduce our method VistrongerDet. The overall method framework is based on Cascade RCNN. The backbone stage performs to extract the features of the input images, generate feature maps. In FPN stage, the fusion from deep layer to shallow layers employ three different factors. Furthermore, the mask head and the fusion module on each layer of FPN make feature extraction paying more attention to object regions, especially to tiny objects. In ROI stage, we perform ROI pooling procedure based on feature maps that fused in the previous stage. For ROI pooling, the features of the current ROI layer and its adjacent layer are specially integrated, and the internal spatial attention mechanism of ROI is also utilized. In head stage, that is our head level enhancement, we take different branches to precise the head categories and tail categories separately. Group softmax classification and multi-label classification are especially used to solve classification of similar categories. Now, let's go into the details of all levels. Wide range of object scale distribution is one interactable issue in the withdrawn dataset. We calculate the number of training samples on each layer with IOU matching algorithm, then get three fusion factors. There exist a lot of tiny objects in the image of withdrawn dataset, which size is less than 32. In order to strengthen the sensitivity of the feature maps to tiny objects, we introduce mask supervision on each layer during the model training phase. In addition, we design a novel module named the Special Attention Fusion to adaptively combine both features. Two ROI with similar size may be assigned to adjacent layers during training. The correlation between the top and the bottom layer is not strong with this one-to-one training strategy. On the contrary, the correlation of adjacent level feature is the greatest, which would contain more surrounding and detailed information. Therefore, we propose adjacent ROI fusion module to fuse ROI features from adjacent levels. We first pull features from adjacent level of each ROI. Then we balance the three ROI features by simply averaging. Finally, utilize the contextual information of current ROI. In withdrawn dataset, imbalanced class distribution is also a serious problem depressing network performance. We exploit two branches to precise head classes and tail classes separately. The head categories branch uses more head category samples to train, while vice versa. In addition, there exist similar categories in withdrawn dataset. For example, pedestrian and people, which are different to distinguish for classifiers since they have many similarities. We exploit a different method that adds several parent classes to classifiers. For example, C1 represent the parents of pedestrian and people, C2 represent the parent of bicycle and motor, and so on. Multi-label classification helps classifiers to learn the commonality rather than repulsion among similar subcategories. We propose a group submax classification by cleverly grouping the similar subcategories into a group and separately executing softmax classification in each group so as to solve the misclassification of similar classes. Finally, I will show some results. Table 2 reports all experimental results while maintaining the same parameter settings. We added the method of VistrongerDet to the baseline and achieved a 1.23% and a 1.15% in AP improvements respectively. Moreover, in almost all cases, AP of each class is improved compared with baseline as shown in Table 3. As shown in Table 4, we gradually added modules at each level to the baseline to prove that these modules are not conflicting. Table 5 also shows the effectiveness of each modules. The above is all the content of our work. Thank you.